Hello, everyone. Welcome to this week's Carto Spotlight. Today's talk is about how we can leverage Carto's analytic toolbox for BigQuery to perform customer segmentation for CPG using trade area characteristics. Customer segmentation is a very important use case for CPG as it allows to understand the merchant potential through their special characteristics of their trade areas and to perform profiling on them. And this is a prerequisite to prior to geomarketing, designing promotional activities based on the characteristic of each store. So it's a really important use case. It's a tedious one, which is usually iterative between different departments, where different KPIs, objective and subjective, are looked into until the final segmentation is complete. With Carto Analytic Toolbox, within Carto Analytic Toolbox, we have designed a set of functions in order to perform this in a much more efficient way, which can lead to an optimized pipeline workflow to facilitate the users to perform customer segmentation based on the characteristics of their trade areas. So this is for spatial characteristics of their trade areas rather than in time domain. This example that I'm going to showcase today is a scenario where we look into locations, stores, merchants in San Francisco Bay Area, in high density urban areas that that the density is quite high, and we look into like how we can do that. So the things that first is required is like to have a set of locations. Now, first of all, we assume that we have the set of locations under like a table, in this case in BigQuery, where it consists of a store ID and the exact location, the POI, the geography of this location. An example can be shown here. So we have the store ID and the geometry of that. Now, the first thing that we do is that we need to design the trade areas for each location. In order to do that, we call the function from Analytic Toolbox, which is called generate trade areas. We pass the location of the stores. In this scenario, there are around 9,000, and then we decide the method that we want. For this example, we've chosen buffer of 500 meters a radius around each location, just because we consider very high density areas. And what this does, it goes to each location and then it designs a buffer. Other methods are available, for example, isocrons, isodistances, and k-ring. An example can be shown here. We have the store locations. These are the points of the locations that we have, that we consider, and these are the resulting, like I will zoom in and then you will be able to see like the trade areas. So for example, for this location, this circle, this buffer of 500 meters around this location is being considered as the trade areas. Now, having done that, having defined the trade areas, what we need to do is to bring the data in. So we need to enrich the trade areas with the characteristics that we want to analyze. Now, this is done using the customer segmentation analysis data function from Analytic Toolbox. This function can include three different things. So the user can pass pre-enriched trade area characteristic that, for example, like from a dataset with sentiment analysis, from a dataset with a store size and so on. The user can also specify some feature from Carto's data observatory or some custom features that has in a table and can use that in order to enrich. For this particular scenario, we will consider 4 different features in order to do this example of how we can do it. Now, the first one is the correct account, which is the number of POIs of merchants that exist within the trade area of each store. And this is done by this query. So the user can pass this query. I can run it very simple and fast. And basically, I can pass this as an input query to the function, which says that this is the store ID, this is the trade area, and this is the number of the stores that exist within the trade area. For this example, we don't consider any feature from Data Observatory, but we consider some custom data that we have, which is related with the consumer spending. It is the annual average expenditure for food at home, food away from home, and alcohol expenditure. And we have this information in the zip code, and then we pass this query. We pass the feature that we want from this query, and basically running the function, it will bring all this information and will enrich the trade areas for each store. So what we've done so far is that we call this function, which is step number 2, and the result of this are three different tables. The primary and the main one is which is called enrich, and it is stored in this location specified here with underscore enrich. This is the store ID and the value of each feature and the characteristics of the trade areas. So we have formed the table with the store ID, the trade area, and the characteristics of the trade areas of the features that we have selected, that we have set to this method, to this procedure, take this feature and enrich the trade areas. Now, for the purpose of analysis and for purely informative reasons for the analysts and for the users, also these functions outputs two other tables. One of them is a correlation table, which shows the correlation between the different features. This is for the analysts to have an idea what happens with the features they have selected. For example, if they have some features that they're very high correlated, maybe it doesn't make sense to include both of them. For example, in this particular scenario that we have food away from home and food at home being 99% correlated, or food at home with alcoholic expenditure. Now, for example, this is a demo, so this is one example, and in an actual use case, we tend to avoid to use very high correlated feature because in a way we include a lot of bias. So it's like double counting different features and adding more weights. But this is up to the user how they want to run the analysis. And the third table are the descriptive of the feature. The descriptive is like some statistics per feature, such as the mean value, the standard deviation, the mean, and different percentile. This is for the user if they want to create some insights, some dashboards to include the insights of the characteristics of the trade areas, what happens globally. This is for that purpose. Now, after step 2, and we have the table that we have enriched with the characteristics per its trade areas, we call the function in step 3, which is called run customer segmentation. To that function, we pass as input the source table of merchants enriched with geospatial characteristics, the table that was the primary output from step 2, and then the scenarios and the number of the clusters that we want to be identified. In this particular example, we say, okay, let's check 2 examples. One with 6 clusters and one with 7 clusters. Now, there is also like another parameter, a PCA explainability ratio, that it's really useful that first takes the feature, perform a PCA, takes out multicollinearity. So in order to avoid this, but of course, this can be skipped or another value can be set and so on. So the output of this function will be the following. So for the scenario of 6 cluster, this store belongs to that store belongs to that cluster, and so on. And also, for the scenario of the 7 cluster, this store belongs to this this store belongs to that cluster, and so on. So this is one of the outputs that we get. Now, as previously, we get more than one table as output. The main one is the cluster that each store belongs to. So in the table, which is specified as output prefix underscore clusters, we get the store ID and then one column per cluster scenario. So in that case, we get cluster 6 and cluster 7. And the value in each column specify to the cluster, to the segment that each store belongs to. So this is actually the output that we want. But of course, we need more than that. We need some descriptive per cluster because, as I told you at the beginning, in customer segmentation, we can have some objective metrics doing the clustering, doing the segmentation, but also we need some subjective. So we want the clusters, the segments to have business sense, to make business sense, to get a meaning out of it. So for that purpose, the output of this table with underscore descript, basically what it does, it gives some statistics per feature, per cluster, per use case. So for example, when we consider 7 cluster, for first cluster, this feature Horek account, these are the statistics. Now, this is really useful for the user to understand which are the features that differentiate from the other clusters and what are the dominant features cluster, because this is really helpful to help the analyst put some labels, put some titles the to the segments, to the clusters. So for example, in the first cluster, if we see very high number like of alcohol expenditure with respect to the other cluster, we can say that in these locations, one of the characteristics that they have is that the people living there, they tend to spend a lot on alcohol. So this is a dominant characteristic. And we can use that in order to form the label. And the third table is a table called stats. And this contains per scenario, like per number of cluster, two different metrics. This is the objective metrics that I told you about, the Davis-Baldwin index and mean square distance. And these metrics are to show like, okay, how different are the clusters, how isolated are the clusters, and so on. Now, the lower the value, the better. It means better separation of the cluster. Now, as you saw, with just these 3 steps, it's very easy like to perform customer segmentation very efficient. And putting the result into a map here, like in Carto Builder, what we put are the locations, and then the color belongs to a separate cluster, to a different cluster. So for example, we can see that we can zoom in into like a store location, and then we can see where it belongs. And then also visually, this is really helpful to maybe to identify some other patterns. Like for example, the yellow one, cluster 3, like we can see that it has a lot of stores here. And if we look, for example, not, to the previous map that we look, that we also have included the spatial characteristic of the trade areas, we can see, like for example, here we saw the alcohol expenditure per trade area. We can see that in these areas where we saw the yellow uh, cluster, we can see very low values. So actually, by overlaying this kind of information, we can start understanding what's happening. And this is what it's really helpful to do the profiling. As you saw, 3 steps, very simple 3 steps that can lead to a very simple, but at the same time, very efficient pipeline workflow. And of course, we can run as many as we want, and we can get all the information rather than doing everything from scratch. So that was today's presentation, how we can do customer segmentation with Carto. I show you these three functions, which are part of Carto's analytic toolbox, how we can use them, and like how we can visualize them on a map, the result, and share the output with the different departments, sharing with colleagues, and to work on it. Thank you very much, everyone, for attending. I hope you enjoyed it, and I will be very happy to answer any questions. Please leave your questions on the comments below, and I'll try to answer them as soon as possible. Thank you very much, and have a nice day.